complex numbers. The proper is something.
This is part of mine. That's Sadie's and that's part of mine.
Oh, geez.
I know you're gonna hate me.
Great. All right. So that's right. I'll just add it. Complex numbers. There are some rules for complex numbers, but the main things to remember are these.
Ew, I don't want to work with
I and I squared. Do you remember what I was? Oh, I have a delay. Really bad.
Really bad.
I squared is 1.
I is an imaginary number.
I squared
Okay?
is -1.
I squared is -1. I is the square root of -1. Okay? We have to have the x-axis, okay? But what happens if you have a scenario that looks like this where he does not cross?
It's imaginary.
It's imaginary. Algebraically, we have to have a solution for that, or a rationale for what the zeros are when that is taking place. And this will give us imaginary zeros. Imaginary zeros. So this is the whole reason why imaginary numbers exist. To get a negative. Not going to happen. So that's why we designate I as being the square root of -1. Okay? I squared would then be, if you just square both of those, when you square a square root, the square root is going to go away. So I squared is -1. Those two things you need to have memorized. Those two things you need to remember, okay? Everything else is pretty straightforward. A complex number will be written in the form of A plus BI, okay? So examples of that would be like 2 plus 3I or 3 plus 6I. Any of those are all complex numbers, okay? You usually write the number first and then the imaginary part after that, okay? Capiche?
Yeah.
Great.
Is it just those 3 or is there more?
No, there's an infinite set. Those are just examples of complex numbers. Good question. Okay? Examples of complex numbers. Okay, so what they're doing is they are equating two complex numbers in this example. You will have some like this and it's very easy. It looks difficult, but it's not. Okay? You have two pieces here and you have two pieces here. Okay? So we're looking at the imaginary part of the left side and the imaginary part of the right side. So the imaginary part over here is -3I, and the imaginary part over here is 4y times I. So if those are the two imaginary parts, we have to set them equal to each other to figure out what the y is. -3I has to be equal to 4 times y times I. I need to get a new pen.
Why'd you throw it away instead of putting it back?
Well, because it works for like the first a little bit. It's not all the way dead. Anyway, all right, so if
4I.
yeah, we can get rid of the 4 and the I at the same time. Can we do that?
No.
Yeah. Divide by 4 and I. Okay, so those are gone. Woo, am I going fast now? So y is equal to, if I simplify the left side, -3I divided by 4I. The i's are going to cross out. -3/4. Now, if that is the case, then what else is equal to each other?
The right side is the left side.
The right side of the non-imaginary part, like the A part. This guy is equal to this guy. Now make sure if he has signs in front of him, they go with each other, okay? So 2x will be equal to -6 divided by 2. X is -3. So if you have two complex numbers equal to each other, you set the real parts equal to the real parts and the imaginary parts equal to the imaginary parts and you solve. Yeah? Good. Fair enough. All right, these down below here, addition, subtraction. You add and subtract i's just like you do x's. You cannot add i's to things that are not i's. So here we have 1 plus I plus 3 minus 7I. Things that I can put together are like the 1's and the 3's, which is 4, and the I and the -7I, which is
6I.
minus 6I, right? Because it's -7. 4 minus 6I, and that is all that you can do. Now, in part B, you are subtracting. What am I going to tell you to be careful? You have to distribute the negative. Okay, so I'm just going to write a middle step in here where I'm dropping the parentheses. 4 plus 3I does not change, but this is -8 plus 6I, and now I can combine my like terms. Okay, so combining like terms, I have -4 plus 9I. That's it. Okay, very, very easy.
Oh, yeah.
What are we doing in part C?
I have no idea.
Multiplying, you're distributing. The 4I gets multiplied here and here. So what's 4I times 2? 8I. And what's 4 times 1/2? 2, and that's 2I squared. Okay, now, this is where we have to do one more little step. If you have anything that's larger than I, like I squared or I to the 3rd power or I to the 5th power, blah, 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 you have to simplify him, right? What do we know that I squared is equivalent to? -1. So this is like 2 times -1, which is -2. So this is 8I minus 2, or if we write that like in the proper form, -2 plus 8I. We usually try to put the real part first and the imaginary part second. Okay, good? Makes sense? Same thing going to happen for D. What are we doing for D? Multiplying, we are just foiling, really. So I'm going to do 2 times 3 first, and then 2 times -4I. So 6 minus 8I, and then I start with the I. I times 3 is 3I. I times -4 is -4I squared. Make sure you put the square on the end of there. Okay? All right, so I squared again is -1. Okay, this +4. Okay, I'm going to pretend that I multiplied him through. -4 becomes +4. Now I combine like terms and I'm done. What do you got? 10 minus 5I. Good? Are we doing all right?
Yeah.
Okay, now the next one is going to be kind of the same thing, except you will notice something real fancy about part A. Okay? Part A, you have 3 plus 2I and 3 minus 2I. We're going to foil this one again, but since we have 3 plus 2I and 3 minus 2I, these two are conjugates. Okay, you know how in Spanish class you find that you conjugate verbs and stuff, okay? Conjugates in math are like finding the opposite, okay? So conjugates of each other would be taking the I and changing the sign in front of it, okay? So if you had like 1 minus 7I, what would be the conjugate of 1 minus 7I? 1 plus 7I, okay? What would be the conjugate of -3 plus 2I? It's -3 minus 2I. You only change the sign of the one that's in front of the I. Good, good. Okay, now they might also try to trick you doing this. Let's say we have I plus 6. What's the conjugate of that? I plus 6. A lot of people say I minus 6, but it's not. You only change the sign of the one that's in front of the I, right? So since that one is written backwards, it's -I plus 6, right? Okay, so those are all conjugates of one another, okay? So when we multiply conjugates together, let's see what happens to them, okay? Something fancy. 3 times 3 is 9. 3 times -2I, -6I. 2 times 3I is +6I, and 2I, what's 2I times -2I? -4I squared, which is going to then become +4 because I squared is negative. You guys get how that works? -4 times -1 is +4. Okay? So when we put that stuff together, you will notice that also in the middle two pieces cancel out. When you are multiplying conjugates together, the middle two pieces will always cancel out. And you will not have an I in your answer, right? What is our answer? 9. It's really 9 plus 4. So 13 is our answer. When you are multiplying conjugates together, you will only ever get a whole number. You will never get I's involved in your answer. Okay, part B. What are they asking you to do in part B? Foil, yes. So remember that you can't just do like 16 plus I squared. That doesn't work. No, don't do that, okay? Don't try to just distribute the 2. We have to actually foil this thing. Okay, so 4 plus I times 4 plus I. Now, are my middle two pieces going to cancel out if I take the same thing times itself? No, only when you have conjugates, okay? So 4 times 4 is 16. 4 times I is 4I. Then we have another 4I. And then we have plus I squared, right? Or plus -1, right? Okay, so I have 15 plus 8I. So only when you multiply conjugates together does that middle two pieces cancel out, right? Only when you do that. All right, good? Are we doing all right?
Yeah.
Okay, now, can I go to the back?
No. Okay.
Back, back? Okay, backside. Now, I to the 54th power. They will do, I think, I've seen this before on like the ACT. Like I to the some huge power, and you're like, how the heck do you do that? What? You've never seen them? I know they have I's though for sure on the ACT.
It was online.
You had on the ACT. Okay, now how do you reduce I to the 54th power?
Would you take it negative? If it's even, it's
Minus
it's
one, minus one,
negative. Or would it be?
Okay, I only know I squared. I squared is negative 1. So we're just going to go I squared. How do you get from I squared to I to the 54th power?
47 power.
27, right?
Negative
Okay, so just wait. 2 times 27 will give me 54, yeah?
Yeah.
Okay,
It's negative 27.
all right? No.
No, it's not negative 27. Where'd you get
So 2
negative
times 27, did we get that far?
I squared.
I squared is negative 1.
You still get one
Okay?
negative one.
I squared is negative 1. So if I take negative 1 times itself 27 times, what's it going to be?
Negative 1.
So it's negative one.
So that's why we have
If you take negative 1 times itself 27 times,
You get negative one.
you get negative 1.
Great.
Okay, do you get that? Does that make sense? Negative 1 times itself 27 times is negative 1. That's it. Okay, now I'm going to do this to you. Let's say we have I to the 55th power instead of 54th. Okay? I'm going to do another example up here at the top, so just write this above. I to the 55th power. I'm going to kind of like that. It doesn't matter. Okay, so I shoved the I off the top. Now, this next one, let's simplify those two pieces before we multiply. What's the square root of negative 4? How does he break down? Okay, so this would really be the square root of 4i, right? But what's the square root of 4? 2. So this is 2i. Okay? What about the square root of negative 9? 3i. That one comes out nicely too. So really we're taking 7 minus 2i times 5 plus 3i, and let's FOIL. So 7 and 5 make 35. 7 and positive 3, 21i. Negative 2i and 5 minus 10i, and what's negative 2i times positive 3i? Negative 6i squared. Yep. Okay? Which is just positive 6, right? Okay, because I squared is negative, so negative 6 times negative 1 is positive 6. Okay, then simplify. 35 plus 6. 41 plus 21 minus 10, 11i. Okay? All right, we're going to skip example 8 because you don't have a problem like that. And to tell you the truth, the difference of cubes, you know how we have a difference of squares?
Yeah.
The difference of cubes formula, I don't even have that memorized. I don't really care about difference of cubes. So we're going to skip example 8. You don't have a problem like that on your homework, but we're going to do example 7. And example 7 may be the most important example on your whole sheet because this is the entire reason why i's exist. Okay, it says find all solutions of this thing. We're trying to find the zeros when we're finding the solutions. So this is basically like saying the zeros. What are the zeros? Okay, now 2x squared plus x plus 3. Okay, can we factor him down? He's like a complex trinomial, right? So we could try to do 2 times 3, which is 6. And what can you multiply to get 6, but when you add them, give you 1? Not going to happen. So we cannot do complex trinomial. Complex trinomial fails. So when that method fails, when the complex trinomial method fails, what do we do now?
I just stick it.
Quadratic formula.
I like
You just skip it. ABC. Do you guys write out your ABC?
No.
Okay, my algebra kids have been doing this, so I'm kind of in a bad habit. 2, 1, and 3. So, negative b. Do you have the quadratic formula memorized? Negative b plus minus square root b squared minus 4 a c all over 2a. Nope. So, -1 plus minus. Okay. I always simplify the next part next. What's -4 times 2 times 3? -24. So, what do I do with the 1 and the -24? You just add, well, you add them together, really. 1 minus 24, right? Is -23 this way. And then all over 4. Okay, so we can put i's in it. So let's change him. The only thing that we can simplify right now is the square root of 23. And we can make him, you want to put the I in the front?
Yeah.
Why not? I square root of 23. Sure, doesn't matter. All over 4. There you go. Okay? So, basically this says he has zeros that exist at this place right here, which is imaginary, which means that this parabola is going to do that of some nature. He's going to look like that. He's not going to have any zeros that touch. Okay? Good, good? All right. That was fast, but that was a lot of problems. So there you go.